Hello everyone. So I am going to discuss a question from CSIR net 16 September 2022, and this question is from statistical mechanics, in which a quantum harmonic oscillator is given, and average energy at some equilibrium temperature T is given to be equal to 2 times the average energy at T tending towards 0. That means average energy of the system is twice the energy when the system is very cold. Okay, so let us calculate this. Obviously, the first step will be to write the energy in different energy levels. So that is for one dimensional quantum harmonic oscillator, I will write that is equal to En is equal to n plus half h cut omega, where n is equal to 0, 1, 2, 3, dash dash dash. And then I will write the partition function. Let us write just for one particle, and that will be equal to summation e to the power minus beta En for different values of n. Okay, so we have to sum all of them, and this will be equal to, so let us put the value. It will be equal to, the first value will be for n is equal to 0. So we will get e to the power minus beta h cut omega by 2 for n is equal to 0. Then we will get plus, you take n is equal to 1, so it will become 3 by 2. So it will become e to the power minus beta h cut omega and 3 by 2. Okay, like that, plus dash dash dash. And this we can see, if I take, just for simplicity, I will take e to the power minus beta h cut omega by 2 as common. I will get 1 plus e to the power minus beta h cut omega. So half and 1 will become 3 by 2, and plus e to the power minus beta 2h cut omega and plus dash dash dash. So this obviously is a GP. So it will be equal to e to the power minus beta h cut omega by 2, and this will be the first term upon 1 minus common ratio, which is e to the power minus beta h cut omega. Okay, now we have to just multiply it by this. So it will come in the denominator and it will be multiplied. So it will be multiplied by this positive quantity. It will become e to the power beta h cut omega by 2 minus e to the power minus beta h cut omega by 2. So let us divide and multiply it by 2 just to make it sine hyperbolic. So Z1 will simply become, so it will become sine hyperbolic in the denominator, 2 times sine hyperbolic. So I can write Z1 is equal to 2 times sine hyperbolic beta h cut omega by 2 to the power minus 1. So this is the partition function. Okay, now the next step is to get the average energy. So what is the average energy once the partition function is known? So I can write the average energy as average energy is equal to minus 1 by z del z by del beta. Okay, so this will be the average energy. So let us just get this. If I write the minus 1 upon this quantity, it will become 2 times sine hyperbolic beta h cut omega by 2. And if I differentiate it with respect to beta, so let me take this, the derivative of this. So it will be minus 1, then 2 sine hyperbolic beta h cut omega by 2 to the power minus 2. Okay, so minus 1, this quantity, minus 1, minus 2, and then into the derivative inside will become 2 times cos hyperbolic beta h cut omega by 2. So that will be the derivative inside the bracket, and then finally with respect to beta I am doing, so I will get h cut omega by 2. So this will be the average energy at an equilibrium temperature T. All right. So this is the average energy that we got at an equilibrium temperature T. Now write it carefully. It will become average energy at equilibrium temperature T will become, so this is this whole will cancel. Here I will get 1, that means minus 1. This minus and minus sign will also cancel, and we have now h cut omega by 2 here, and what you will get this by this, you will get cot hyperbolic beta h cut omega by 2. So this is what we are getting at equilibrium temperature T. Now what will be the limiting value? If I calculate E T at 0, I will get h cut omega by 2, because the limiting value of cot hyperbolic h cut omega by 2 kBt, because beta is equal to 1 upon kBt. So the limiting value will become h cut omega by 2. And now if you compare, what you are going to get is, so let us compare it. So here 1, 2 is also there. 2 times okay. So now just we have to write the final equation, that is h cut omega by 2 cot hyperbolic beta h cut omega by 2 is equal to 2 times this limiting value h cut omega by 2. So this will cancel and we will get cot of beta h cut omega by 2 is equal to 2. So that's why this is the correct option, which is with option ID 70. And if you want to understand here why I have taken this value is equal to 1, you can see it like this, that we had cot of hyperbolic h cut omega by 2 kBt. Okay, so we have to put t is equal to 0. So let us take kBt by h cut omega, kBt by 2 kBt by h cut omega is equal to x, like this. So it will become cot hyperbolic 1 by x. Okay, so you have to take a small value of x. So this is the procedure I am telling you, you can use in almost every question where you want to calculate the limiting value. So cot, this can be written as e to the power 1 by x plus e to the power 1 by x upon e to the power 1 by x minus e to the power 1 by x. Okay, you take e to the power 1 by x as a common. So what you will get? We have to take x is equal to almost very small. So take e to the power 1 by x common. You will get 1 plus e to the power minus 2 by x. Okay. If I take e to the power 1 by x common, here we have minus. So it will become minus 2 by x upon e to the power 1 by x will be 1 minus e to the power minus 2 by x. So this will cancel, and at x tends to 0, as x tends to 0, it will become 1 plus e to the power minus infinity upon 1 minus e to the power minus infinity, that will be equal to 1. So this is how we calculate the limiting value. So this is very normal thing in almost each and every calculation. In hyperbolics, we convert it into exponential function and then we can handle it. Okay. So this is not a new thing. So this was the question. Okay. Thank you.